Statistics with Mustafa. Today we're going to talk about a very important and high priority test, which is multivariate analysis of variance, Manova. So what is Manova? Is in sample terms, Manova is like Manova is widely used also and a parametric test, but instead of testing only one dependent variable, it used when we have two, for example, or more dependent variable or continuous outcome variables. For example, if we want to test whether the species as a grouping variable or independent variable, also categorical variable, has an influence on several dependent variables, we could run ANOVA or separate ANOVA for each one of dependent variable, but that would increase redundancy and the risk of error. Instead, Manova combines them, for example, for one, them into one model. Also, remember, Manova can only be used when we have at least two or more dependent variables. Now let's load these packages, and we want use this data set iris. And let's look at the assumptions in Manova. The first assumptions refers to adequate sample size. We can follow the rule of thumb, and we can apply the table function to the iris. Select iris as data frame, and select species. So in this case, the rule of thumb corresponds that the number of observations of each group in each group should be greater than the number of dependent variables or dependent outcome or continuous variables. So in this case, we have 50 as observations of each group, which refers that this number is highly greater than the number of dependent variable, which is 4. So the first assumption of adequate sample size is met. The second one refers to the independent of observations. This means that each individual, in our case, belongs to only one group, either Setosa, versicolor, virginica. There are now repeated measures on the same subject, here or here or here. So if this study design ensures this, then then the assumptions is met. Move on to the next assumptions, or the third one refers to absence of multivariate outliers or univariate outliers. So multivariate outliers using the Mahalanobis test or distance unset test. So we can check this assumptions using the Mahalanobis distance by calculating Mahalanobis distance from the package statics. So we can use this comment, for example, iris % more than %, and group by species S with uppercase species sorry, my bad, % more than %, and right Mahalanobis distance. So we can use the view function, view as this way, between parentheses, and check it or to explore the results. So we can check that here the results of Mahalanobis distance, and by calculating the Mahalanobis distance for each observations and checking the results, we can here identify if there are any extreme multivariate outliers. In our case, I think no such outliers were detected. So this very well. So this assumption holds. So the assumption of absence of multivariate outliers is met. Moving now to check the absence of or The fourth one, which refers to univariate and multivariate normality using the Shapiro-Wilk test from the Eurostatics package, iris percent more than percent, and right group by species and percent more than percent, and the right Shapiro test. Here we might need to write the for dependent variable between them a comma, like this way, each here one, and also here, now here, and then here. So sepal weight follow a secure distribution in Setosa, and also versicolor with a dependent variable petal width also follow this non-normality distribution, and the same case in the Virginica. So instead to remove petal width, we might want to check the first if there is absence of multicollinearity using the GGALI package library, and to check two assumptions in only one function, and check it with the function GG pairs, iris, and select and aesthetic graphical color equal to species. Very well. So when the correlation between dependent variables is very high, for example, above 0.9, in this case, that case, we need to remove one of the highly correlated variables. After doing so, we should check the assumptions again, assumptions of normality and multivariate normality. In this case, I think we have petal width is highly correlated with sepal length, and also petal length with R, or coefficient percent of correlation, is more than 0.9. In this case, we need to remove petal width to avoid the multicollinearity, or to get assumptions of absence of multicollinearity, and then we might need to recheck again the normality of distribution, and not only univariate normality of distribution, and also multivariate normality of distribution. So in this case, I think we need to, or we must, to remove or exclude the petal width, like this way, iris, comma, -c. First, I want to check the number names of petal width. The petal width is the fourth column, so here put 4. In this case, I think there is no highly significant or highly correlation. So all the R, which refers to coefficient of correlation Pearson, is lower than 0.9. So there is no multicollinearity, or the assumption of absence of multicollinearity is met. Also, there is linearity between the dependence variable, as show with the scatter plot. So the linearity between the dependent variables is another assumptions. So in this case, the assumptions of linearity and absence of multicollinearity were met. So we'll check again this assumption of the univariate normality without petal width, I think, yes. without petal width, yes. So we might need to remove petal width. So only petal length, sepal width here, and sepal length. Very well. So the p-value, all the p-value is more than 0.05, and also the p-value here. So we can conclude that the univariate assumptions of normality is met. So move on to the multivariate assumption of normality using Shapiro test. Iris, percent model percent, and group by species, and percent model percent Shapiro test formula statics package. In our case, the output, there is an error here. I think, sorry, my bad, I misunderstood here this case. We should remove this one and select to, because we have, in this case, need to check the multicollinearity, not the univariate. Instead of the multicollinearity, you need to check the multivariate normality. So select the appropriate dependent variable here, and then percent more than percent Shapiro test. So the p-value indicates that there is no multivariate, or this assumptions is met. So there is no p-value more than 0.05. So these assumptions of univariate and multivariate were met in our case. Moving now to the second, or to the assumptions, I think after checking the absence of multicollinearity using GGPace from GGAli package, and also the linearity, and also the univariate normality, multivariate normality, Mahanobis for testing the absence of outliers, the independence of observations, and also the first one, which refers to adequate sample size. We have only to check two assumptions, which is homogeneity of variance, and another one which refers homogeneity of covariance matrices. Homogeneity of covariance matrices also refers to as multivariate homogeneity of variance. So I will repeat, in our case, when we check the univariate normality, we have conclude that I think petal length, yes, no, petal width, yes, petal width, yes, petal width isn't follow normal distribution. So instead, in this case, we continue the next assumption, which refers to check the multicollinearity. Why is this important? Because sometimes a violation of in our case here of a violation of normality here is related to very high correlation, like here or here, correlation among the dependent variables. So if we check the correlation and find that one, like this one, the petal width is highly variables has a very strong correlation with the others. For example, petal width above here than 0.9, then we might decide to remove the petal width as we have applied. So after excluding this variable, we can check again the assumptions of multivariate and univariate normality again. After this, I think Manova, yes, one of key assumptions is assumption is homogeneity of covariance matrices. Homogeneity variance covariance matrices tested with boxes M test. This test is very sensitive, and so we use alpha equal to 0.001 instead to alpha equal to 0.05 in the case of, for example, Shapiro or Shapiro Wilk. So we can, for example, following this command, box m, box underscore from rostatics package, select iris, yes, I think here, iris, yes, very well, and dependent variable between double quotation marks, here, like what, like this, very well, and then iris, for example, now here, C, okay, very good, and comma, iris, and select species. So the box M indicate that the results is very less and high, less than 0.001. So the assumptions of homogeneity of covariance matrices isn't met. In this case, instead to use the Wilks statistic, we need to use the alternative one, which is Pillai's trace. So in the case of the violation of assumptions of homogeneity of covariance matrices, we have alternative test, which is very robust test, is Pillai's test. So we might want to check the last assumption, which refers to the homogeneity of variance using Levin's test. Only I want to add or create a new data set. For example, like refers to iris, for example, 2 equal to iris data frame, for example. And we can check it here with head function, iris2, the same one of iris. And write this comment, iris2, for example, equal to iris2 also, percent more than percent, and use the function gather to create a new variable column, which is a variable corresponds to the 3 variables, and another column refers to value of all values of these 3 variables. K equal to variable, and also value equal to, but in double quotation mark, value also, and select the only 3 dependent variable. I think petal length and sepal width and sepal length, yes, between them comma. Very good. I think head, check it again with the head function, iris2. Very good. So we have a species at grouping variable, and the variable refers to 3 dependent variables, and the value is the values of each variables on the appropriate group. Then we could check the homogeneity of variance using Levin's test. Following this comment, iris2 percent more than percent, group by, because we have many of dependent variable, and select variable. The same case of dependent or univariate, when we want to check univariate, I forget the assumption, univariate normality, yes. So, and put here Levin's test, and write value tilde species. So in this case, the p-value of petal length and sepal length is less than 0.05, so the assumption of homogeneity of variance isn't met. But I have a solution. It refers to transform the values of all variables using the log transformation. I think I can do it with this way. For example, iris 2, select. Now, I think I want to create another data set, iris 3, and select iris 3. Sepal length, yes, sepal length equal to log, also again iris 3, and select also sepal length. The same case of the sepal length. Oh no, the same case of the petal length and sepal width. I will copy it and paste it, and select another one, which is sepal width, and also here to transform the data. Sepal width, oh, very good, and select in this case petal length. We have sepal length, sepal width, and yes, petal length, and also here instead to put sepal length, we select petal length, and we'll check again the iris 3. So this is the value. This value refers to the value of each three dependent variables after transformation, after log transformation. And we might need to check again the Leibniz test after transformation. But here, instead to put iris 2, we might need to put iris 3. And I think, yes, I think we need to also transform the data here, or create a variable here, but with iris 3. These different, I think, and now iris 3, yes. So I can check it using head function, iris 3. Very good. This is the results of sepal length after transformation. Yes, after transformation. So, and we'll check again the Leibniz test, or the homogeneity of variance. In our case, the homogeneity of variance is met because all the p-value of the three variables is greater than 0.05.